In this video, that's okay, I can trim that. In this video, we're going to get a brief introduction to earthquakes and learn how earthquakes have been very helpful for scientists to determine the properties of Earth's interior. Earthquakes occur due to the movement of Earth's lithosphere, which is made up of the crust and rigid mantle, and this happens along fault lines. So here's a diagram showing the movement of Earth's crust and the resulting earthquake. When earthquakes occur, they occur within the crust, and we call that location the focus. Directly above where the earthquake occurs, directly above the focus, on the surface of the Earth, we have the epicenter. Oftentimes, when you hear about an earthquake on the news, they'll mention where the epicenter of the earthquake was. That's just the location on the surface of the Earth that had the earthquake. Now, when earthquakes occur, they produce these energy waves that we call seismic waves. And these waves travel outward from all directions from the epicenter. So in this diagram, the epicenter is represented by that red dot. And as you move away from that red dot on the surface of the Earth, you can see the circles moving outward that get larger the further you go from the epicenter, which is representing the movement of the seismic waves. So although an earthquake happens at a particular location, for example, the epicenter, other locations can still feel the effects of the earthquake because those seismic waves can travel across the Earth. And when you feel the shaking from an earthquake, that's the seismic waves moving through your area. So here's an animation that's going to show the movement of seismic waves. Now there's two main seismic waves that we're going to learn about in this class, and they are called P waves and S waves. In this animation, P waves are shown in dark blue and S waves are shown in light blue. I'm going to play this animation through once, and then we're going to learn about the first difference between P waves and S waves. So here we have the P waves in dark blue traveling further and faster than those S waves in light blue. So now we can learn a little bit about how these seismic waves get their names. P waves are called primary waves because they travel faster and they arrive at a location first. S waves are called secondary waves because they travel slowly and they arrive at a location second. So here is a graph showing the arrival time of P waves and S waves after an example earthquake. So when the earthquake waves arrive to an area, the P waves will get there first because they travel faster, and then the S waves will arrive second because they travel slower. So when an earthquake happens, both P and S waves are generated, but due to their properties, P waves arrive to a location first, the S wave comes later on. So now I want to look at this animation again, but this time I have the layers of the Earth's interior labeled. We have the crust that's not labeled because it's so thin, it's hard to determine where it is within the diagram, but an example of the crust is where the earthquake is, represented by that bright green dot. Then we have the mantle, outer core, and inner core. As we look at this animation, now I want you to focus on how the P and the S waves travel throughout those layers. Because what's really unique is an earthquake can happen in one part of the world, but the waves have the ability to travel through Earth's interior to the other side of the Earth. So here we're going to watch the P waves and the S waves, and I'm going to pause for a moment because there's a major difference that's happened here. The P waves in dark blue were able to go through the outer core, but the S waves shown in light blue did not go through. And that's a really important discovery for scientists. So here is an image showing this exact process again. What scientists have been able to figure out is that S waves are absorbed by the outer core. They can't travel through it. P waves can, but S waves cannot. This allows scientists to conclude the following. Through laboratory experiments, scientists were able to figure out that S waves do not have the ability to travel through liquids. This allowed them to conclude that the outer core consists of liquid iron and nickel. Since S waves cannot go through it, it's concluded that the outer core is liquid, and that's a major, major discovery about the properties of Earth's interior. Here's a diagram showing all the layers of the Earth, how thick they are, what they're made up of, are they solid or are they liquid? We got all of this information from earthquakes. Seismic waves, they travel at different speeds and will behave differently depending on the type of material that they travel through. Scientists have been able to use seismic waves and how they've traveled throughout Earth's interior to help determine the structure and composition of these layers. Because remember, humans cannot get through the crust. We cannot physically see those layers or extract material from those layers. So earthquakes, specifically seismic waves, have been so helpful to scientists to determine the properties of Earth's interior. So this animation is going to show something slightly different. So remember, when an earthquake happens, the seismic waves have the ability to travel throughout the interior of the Earth and can reach locations on the opposite side of the Earth. So this animation is going to show a visualization of seismic waves traveling across the Earth due to the earthquake. And you'll see that there's two regions that didn't get any seismic waves at all. We call those shadow zones. You'll notice that as the seismic waves were traveling across the Earth, that some of the waves started to bend. The bending of waves is a process called refraction, and this results in the earthquake shadow zones. So on any given earthquake, there's always going to be locations that do not receive any seismic waves at all, and we call those shadow zones. So here is a diagram that's going to represent an example earthquake and what locations throughout the Earth were able to receive seismic waves. So the first thing I want to point out is the layers. We have the mantle, outer core, inner core. The crust is the thin circle that encompasses the whole diagram. Within the P waves are a solid arrow, while S waves are represented by a broken arrow. So let's first focus on location X. Location X was able to receive both P waves and S waves from that earthquake. If we take a look at locations W and Z, you'll notice that they only had P waves. That's because location W is in the outer core, and in order to reach location Z, the waves have to go through the outer core. Since the outer core is liquid, S waves are not able to go through it, so only P waves were able to reach those specific locations. Then if we look at location Y is in the shadow zone, so it did not receive any seismic waves due to the process of refraction.